In this video, I will be taking some slight detour from, me talking about a bunch of LeetCode problems. I actually want to dedicate some time talking about probability. And you may say, why probability? I think probability itself is a very challenging topic. At least for me, I think probability is very, very helpful topics, especially in finance, like when you are doing some gambling, right? Horse race betting. So probability is currently slightly overlooked. It is the topic that not many people, at least on the YouTube channel, I don't see many people talking about probability. So what is probability? How is it different from statistics? Well, to explain this in layman's term, probability is more about we are looking forward, like what we should be thinking about the future, how to put us in the best possible position for the future. Or in other words, probability is about like we care about where we are heading. Statistics, on the other hand, is quite useful in looking back, given the data we have. So, that's how I think about this, like the difference between statistics and probability. But nonetheless, I want to talk about probability, statistics, and then linear algebra. So in this video, we will be talking about gambler's ruin problem. So this is very popular topic in the intro stochastic process classes. But yeah, let's look at the problem. We have a setup. We have two players, player A and B, and they will be playing a game. And they will be playing this game many times. And the probability of player A winning is given by P, and that means probability of B winning is given by 1 minus P, and then we set that equal to Q. And then we assume that the matches are independent. What does that mean? What is independence here? Suppose you and I play this game, and I won this match, and then we are playing the same match again, but me winning the previous match has no influence on our current match, meaning that if I won the previous match, that does not mean I am more likely to win the match against you. So the previous result does not influence our current match. So that's what it means by independence. And then each match is following the Bernoulli distribution with P. P is the probability of success, and in this case, P is about the player A winning. So the result is following Bernoulli distribution, and then the result can take either plus or minus 1. And that's gonna be handy because when player A wins, he or she will be gaining like $1 more, and then if he or she is losing, that person will lose $1. So let's say player A starts with initial capital K, and player B starts with initial capital A minus K. So this already assumes that A is bigger than K, otherwise player B starting with negative capital does not really make sense. Okay, so we will be defining random variables. Let xn be the random variable, and that subscript n means that, so it means that we have played like n matches so far, and then x of n will be the player A's like the total net worth after playing n matches. So that means x of 0, that means you have not played, like player A and B have not played game initially, so x of 0 will be K. That's the initial capital that player A starts with here. And then x of n equal to 0 means player A is bankrupt. Okay. And that means player B won the game. So the question is, how do we derive P probability of player A going bankrupt? So that's what we want to find out. And notice that n has to be greater than or equal to K. Why is that? Well, so the minimum number of games that you have to play, player A has to play against player B. For player A to lose the entire fortune is K, right? So that's why n has to be greater than or equal to K. Okay, so we have x of 0, x of 1, x of 2, like those sequence of random variables. And for each random variable, the sample space is finite, meaning that x of I can take value from 0 to a. Okay, so any number between from 0 to a. Okay. And let's define another random variable. Like, it's not technically defining, we are just come up with another variable. So C of k will be the event that player A is eventually ruined with like starting capital of K, and we want to find out the probability of C of K. So C of K, the event itself, will be equal to, so this means essentially C of K equals union of x of n equal to 0, where n is from k to infinity. And when you apply the probability, we get probability of C of k is equal to sum of all this probability from n equal to k to infinity. Okay, and this part I already talked about this. And then the second part is this. Remember I said the events, like all these individual matches, are independent from each other, but then the random variable themselves are dependent. What do I mean by that? Suppose player A played like 7 games, and that person has capital of 10. And this can only happen if our previous state, meaning that our 6 games, I either have like capital of 9 or 11, right? So that's what this means. So this can only happen if the previous state has either x minus 1 or x plus 1. So that is why these random variables are dependent from each other. Okay, so we will be denoting so we want to find probability of C of k, and let's denote U of k to be this guy, just to simplify the notation. So as I talked before, from U of k, we either have U of k plus 1 or U of k minus 1. This means player A won the match, or this means player A lost the match. And then so how should we find this U of k? I don't know if you guys remember this, but remember like this law of total probability. So meaning that let this be our like total sample space, and we can partition this sample space into 4 sections, right? A1, A2, A3, A4, and let B be another event that's something like this. So we want to find the probability of B happening, and B itself is just equal to union of like all these like 4 intersections here, and each intersection is given by B intersect like A1, this one will be B intersect A3, and so on. And you apply the probability, and we get probability of B is equal to summing from like I equals 1 to 4. And then this guy, we can write it as conditional probability, meaning that this is probability of B with A of I happening. And so yeah, condition to this happening was the probability of B times probability of A underscore I happening. Okay, so we'll be using this concept to solve this finding the UK. So applying this law of total probability, we need to know this. So initially, so starting from here, so how do you get to this part? Well, you get to this part by winning the match, right? So let D be an event where A wins. That means D complement means the player A loses the match. So using this law of total probability, we have probability of C of k is equal to probability of C of k condition to D happening times probability of D. And then this one is same thing, C of k condition to D complement times probability of D complement. And so probability of D, meaning that probability of player A winning, is given by P, and this part will be given by 1 minus P, which is equal to Q. So we have U of k equals U of k plus 1 times P plus u of k minus 1 times q, and then you move this one to the right hand side, we get p times u of k plus 1 minus u of k plus q times u of k minus 1 equals 0. And this is what we call second order linear homogeneous difference equation. So notice that we have a difference equation, not differential, because we are dealing with discrete time. And so unfortunately, not many book talks about how to solve this difference equation. But anyway, we have a second order linear homogeneous difference equation. Yeah, it's a fancy way of saying this kind of equation. Why is it second order? Well, what's the time step here? K plus 1 minus k minus 1, that will give us 2. So that's why we have a second order linear homogeneous equation. Okay, so here is our difference equation. P times u k plus 1 minus u of k plus q times u of k minus 1 equals 0. And then our k goes from 1 to a minus 1. Now, difference equation, just like differential equation, we do need boundary condition to solve this equation. So what are the boundary condition? When k is equal to 0, that means player A's capital will be fluctuating, and then when it hits 0, that means the game is over, and then the player A just lost the game. Okay, so in that case we have u of 0 is equal to 1, and when k is equal to 8, that means player A won the game and player B is bankrupt. So this is how we summarize our difference equation. We have this difference equation. So notice that k is from 1 to a minus 1, and for k equal to 0, this is what we have. For k equal to a, we have this. So how do you solve this kind of equation? You can do it in iterative way, and another way would be just like how you solve differential equation. We will be guessing the form of solution and then try to find all the missing puzzles, like missing information. So we will be talking about 2. I can talk about 1, but let's first talk about 2. Okay, so this is our difference equation system. This is our difference equation that we have to solve. And let's guess that our solution takes the form of this, m to the power of k. Now, m is unknown, so we have to find m. Okay, so we will be substituting m to the power of k into this equation. That will give us p times m to the power of k plus 1 minus m to the power of k plus q times m to the power of k minus 1 equals 0. And you can pull out m to the power of k minus 1. We will be having this kind of equation. Now, since this set equal to 0, for this to be equal to 0, we have two cases. Either this itself, m to the power of k minus 1 is 0, or we have the expression inside this parenthesis is equal to 0. But if this is equal to 0, that means we have m itself is equal to 0, and that is a trivial solution, so we don't want to look for that. So we will be looking at this guy. Okay, so we want to look for a non-trivial solution, and we basically have to solve this. P times m squared minus m plus q is equal to 0. And in math, this is known as the characteristic equation. So how do you solve this equation? So we'll be factoring this equation. We get something like pm minus q times m minus 1 is equal to 0. That means either this is equal to 0 or this is equal to 0. So if this is equal to 0, we have m is equal to 1. So that is our one of the roots. So one root is equal to 1. Then another one will be pm minus q equals 0. So that will give us m equals q over p. So we have two roots, m1 and m2. Now notice that our equation here is a linear equation. So the solution itself will be some sort of linear combination of m1 and m2. So how do I express that? uk will be equal to a1 times m1 to the power of k plus a2 times m2 to the power of k. So that's that. And then substituting this m1 equals 1 and m2 equals q over p, we have a1 plus a2, and then we have a q over p raised to the power of k. Oh, and we are not done yet because we have to find a1 and a2. So how do we find a1 and a2? Well, which information so far we have not used? We haven't used boundary condition. So we will be using boundary condition to solve for a1 and a2, and then we will be done for this problem. Okay, so when you use boundary condition, we have, so using these boundary conditions, we have a1 plus a2 equals 1, and a1 plus a2, and then we have times q over p raised to the power of a equal to 0. So you can solve that. It's a very simple linear algebra problem. Then we get a1 equals negative, we have a phi over 1 minus phi raised to the power of a. a2 is given by this, and then our phi is given by q over p. Now notice that, so our u of k will be something of this form, where phi is q over p, and this is for p is not equal to 1 over 2. If p is 1 over 2, we do have to modify something here, but I will talk about it in my next video. So anyway, that's the probability of, player A. What is our u of k? U of k was the probability of C of k, and C of k was the event that player A is eventually bankrupt. So that is for this video. For the next video, I will talk about the case where PA is equal to 1/2, and then I will do some more problems on, like, from Gambler Ruins problem. There are many modifications, and so yeah, and hopefully my goal is that I can talk about the setting the foundation for me to talk about Kelly's formula, like it's the so-called wealth generating function. But anyway, that's for this video. I hope you guys have a great upcoming weekend, and I will see you guys in my next video. Bye bye.